Hello everybody, today we are going to talk about another two types of loops, about the while and do while loop. Let's start this topic from the while loop. It looks like that. While, parentheses, in parentheses there is a place for the condition, and after it of course we can set the instruction to repeat. So for example, cout la la la. Okay. And let's create a condition here. So for example, when I is lower than 10, but of course we have to create the integer number before that loop. So for example, I will assign number 0 here. And look, we can't set here our variable inside the loop. We can't increment the variable inside that parentheses. We can't do that here. We have to do that always in the body of our loop. Okay, so we have to create a block of instructions. Sorry, it's a bit different from the while loop, but it works almost the same, right? Let's see. Right now I will just run it, and as you can see, our condition is right now always true because 0 is always lower than 10, right? The I is not changing. If I change the I, for example, I will do something like that, then this thing will be run 10 times, right? So, well, let's maybe send to the output I and do something like that, right? Let's see. As you can see, we have 10 numbers here. Okay, so it's working like the for loop, and now you might be like, so why do I need to know how that guy works here, how that loop is working? Because one person will use the while loop, second person will use the for loop, and you need to understand how they work. You will also have to decide what loop you like more, the for or maybe while loop, okay? And let's train a bit. Let's see how does it work, for example, when we do something like that. Let's go back to that position, and for example, I will increase the variable I here. What's going on? Can I do something like that? Of course. If you don't remember how post incrementation works, please go back to the arithmetic lesson I was explaining there it very clearly. As you can see, we have 10 numbers here, and they are beginning from 1 and it's ending at 10. What if I do something like that? As you can see now, numbers end at 9. And why is it happening? Because as I said, the pre-increment operation works like that. For example, let's assume that we are already at the number 9. So pre-incrementation works like that we have to first increment the I, so it will be 10, and then we have to send it to the output. So it will be like, if 10 is lower than 10, no, that's why 10 is not sent to the output here. But when I do something like that, is I lower, is I when it's 9 lower than 10? Yes. And after checking if that 9 is lower than 10, that 9 is increased by 1. So that's why here we have also 10. Okay, that's how it's working. And look what we can achieve here. Very cool. For example, we could also count to 0. We could do something like that. And what will happen? Let's see. As you can see, we are counting from 9 to 0. When I do it that way, we are counting from 9 to 1. And why is it happening? Let's focus for a second. When condition is true, when it is not equal to 0, so when I is finally 0, that loop will stop executing that instruction here, right? So if We have 10 here right now, so we are just decreasing. We are sending to the output 10, then we are decreasing by 1, so we have 9. And at the end we have something like 1, sending 1 to the output. We are decreasing it, so we have 0. So we are sending that 0 here, right? And then what's happening? We have decreased that with the increment operation, right, by 1, and we have 0 already here, so we can't repeat it again. When I do something like that, when I is 1, then we have to decrease it by 1, so it's 0, and we are checking if condition is true. So 0 is false, so the condition is false, and we won't send 0 to the output. That's how it works. Let's train maybe a bit on assigning values to the arrays. So for example, let's do something like that, and now if I is lower than 10 and I create an array that size is 10, I could do also something like that, constant size of array, and of course I have to add that it's integer, and I will assign here value, for example 10, so it will be easier if we change anything, right? We can now change only here that value, and it will be changing every place in our program. And now let's assign values. So array of I equals, for example, let's just assign to every value of every element of array 10, for example. We can of course do it that way, but we want to do it the harder way right now. But we can of course, for example, multiply it by I in addition. And now let's see what will happen. I will of course increase that I. And let's send to the output what we have to do it that way. Okay. As you can see now, everything works fine. We could also increase the value here. Let's see if it's working the same. As you can see, the output is the same. Because the post incrementation works like that we have to first send to the output. So at the start we have 0, so array of 0, and then we have to increase the I. So I will be increased in the next round of loop, right? Okay, this is the while loop. We have also something what is called do while, and this is very it is a bit different loop from other loops, because look, we can do something like, for example, do while, and I will do send here I. Let's comment that guys here, so they won't disturb us. And right now I is what? 0. So the condition is not true, but let's see if that instruction here will be executed. As you can see, it got executed once. So this loop is not checking the condition at the beginning. It is checking the condition after execution of every instruction between the curly opening bracket and curly closing bracket. In the while and for loop, the condition is checked at the beginning. So when I do something like while I and then cout la, then as you can see, this guy wasn't executed at all. So the condition is checked at the beginning. There's a difference between do while loop and while and for loop, okay? Okay, that's all in this lesson. Hello everybody, today we are going to talk about break and continue instructions in loops. Well, as you can see, we have got here a code from the previous lesson. And I remind you that code is sending to the output the multiplication table. Now I'd like to tell you what is responsible for the the external loop, and what is responsible the inner loop. Let's check it out. I will increase, for example, that guy to 15, and we will notice that we have got now 5 more rows. It means that the external loop is responsible for the amount of rows. When I decrease that guy here to the 5, well, notice that we have 5 less columns, so it means that this guy is responsible for the amount of columns. We'll also notice that when we are increasing number of rows, we are also increasing what? The length of column, right? Look, when we decrease that guy to, for example, 7, we'll notice that the column is shorter, right? So this guy is responsible also for the length of column. And this guy is responsible for the length of row. Okay. So, that's how it works. And now I'd like to tell you about the break and continue statement. Let's imagine a situation like that. I want to show all rows, all 10 rows, but row 5. So I don't want that guy here, right? When I build it, I want to have all rows but numbers 5, 10, 15, 12, and the 25. I don't want to see that guy either. What to do? In order to do it, we have to use the instruction continue. So if that loop with that variable here is responsible for the rows and we don't want to see that row, we have to check if I is equal to 5 and then use the continue instruction. Right now you'll see that we don't see anymore that guy here, the row 5. So we have achieved what we wanted to achieve. But how does it work? What is that guy doing here? Well, continue is working like that. Everything after continue instruction won't be executed. So everything after, so that guy's here, won't be executed. But loop will not end because of it. It means that we are skipping the code after the continue, and after it we are increasing I by 1. So we are increasing I by 1 and we are checking again if I is lower or equal to 10. Because it is true, we are again going to execute instructions. We are checking if I is equal to 5. No, because 6 is not equal to 5. And because of that, instruction won't be run again, the continue, because I will be increased, right? And everything after it is going to run like it was before. So it's good. Okay, so this is the continue instruction. It works like that. Now I'd like to tell you about the break instruction. What will happen when I do something like that? Break. As you can see, we can't see right now anything after the 5th row. So break is working like that, that everything after break won't be executed, and we are leaving the actual, it is very important that word here, actual loop. So our actual loop is right now that guy here, the external one. And because we are leaving it, it means that we'll run instructions here. La, la, la. They will be run very well. But what would happen if I did something like that? If j is equal to, for example, 5, and I will do break here. As you can see, we lost all columns here because j is responsible for the columns, but all the rows to 10 were executed fine. So when our PC meets with the break, it is leaving that loop and it's going to execute that enter here, and after it will go to that incrementation here, it will check condition, and again. So it is leaving the actual loop. Okay, and what if I do the continue here? You'll notice that we don't have only the fifth column. That's how it works. And now I'd like to train a bit on, let's imagine a situation like that. I want to have right now one loop that will do the same as that two loops. Wow, how to do that? Let's comment that, guys, here. But we can't do that because we have comments here. Let's delete that. Let's do that way. And now I will send to the output the first line, like before. So I++, and now cout with and cout I, and let's create the j here also, because we have only one loop, right? And as you can see, well, it's because of the line, I shouldn't add it here. We have got only one row. Cool. And if I wanted to have more than one row, I should increase the j, right? So let's do that. I'm going to increase j now. And what's going to happen? As you can see, we achieved wrong numbers here, right? Because right now we are increasing the j and we are increasing the I at the same time, and because of that we have got multiplicated 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6, 7 by 7, 8 by 8, 9 by 9, and 10 by 10. Okay, so we should increase that guy only when our I is equal to 10. We can do that, but before that, no, it's not good. So right now we have only one row and everything works like we wouldn't have it at all here, right? Why? Because condition here, when I is 10, is not met, and of course that incrementation won't happen at all. Okay, so we should also assign 0 to I, so it will keep running, right? And right now, let's see how it's going to happen. As you can see, it will run almost forever. So, because our condition will never be right now false, because we always assign 0 to I when the condition is almost to be false. So we have to also check, we have to break, we have to leave from that loop when j is equal to 10 plus 1. I will tell you why the plus 1 is here soon. Break. We should also add enter after each of row. And as you can see, we have got right now multiplication table by using only one loop. Of course, that is a bit more confusing, at least for me, than that thing here, than nested loops. So it's a rather training of break. And let's see how it's working now. So right now we are multiplicating I, so at the beginning 1 by j, which is 1, and after it we are just skipping that guys here because the conditions are not true, they are false, and we are increasing I, we are checking condition, and we are multiplicating 2 by 1, 3 by 1, 4, 5, 6, 7, 8, 9, 10, and finally when it's 10 we are checking that condition is finally true, and we are increasing j, we are assigning to I 0, we are creating the end line, so we are creating the enter, and we are checking that condition which is not true, and again we are multiplicating now this time 1 by g, which is now 2, so we have got now 2, 2 by 2, 3 by 2, 4 by 2, and again when I is 10 we can increase that guy and but when finally g is 10, we are skipping some rows of course, when g is 10 we should also run that code, that multiplication here, because you want to see the 10th row. If I did it that way, you'll notice that we are not seeing now the 10th row, because we must remember that when our PC meets with the break instruction, we are leaving the loop, right? Because we have to add here the plus 1, because we want the 10th row to be also executed, right? To be also sent to the output. Okay, that's all in this lesson. Thank you very much. Hello everybody, today we are going to train loops and we'll talk about the nested loops. Okay, let's start from training them. Let's make a program that will tell us how many digits are in, for example, integer number. So when I create a number, for example, like that, and I will assign to it value 1234, I would like to see that our program will tell us that this guy has 4 digits, right? And when I increase the number, I want our program to tell us that it has 5 digits. Okay, and how to do something like that? Look, when I do something like 1234 and I divide it by 10, what will be the output of that operation? Let's see. As you can see, it's 133. So when we divide two integer numbers, we are losing the value after the point. If I divided it that way, I would have the right result, right? But right now we'll use that dividing two integer numbers give us the number that is one digit less. Okay, so it would be something like that. Now let's imagine situations like that, and let's see what's going on. Now, as you can see, the last guy is 0, so 1 divided by 10 is 0. And now we can think like, hey, 0 for the condition in loops means false. So if I divide in condition that number, finally it will be 0, so our loop will end. And as you can see, that thing got how many times divided? 4 times. How many digits we have here? 4 digits. Great. So we can create next variable, for example, number of digits, and it will store the number of digits. Let's start from 1, and I will do something like that. While we can divide number by 10, increase number of digits, right? And after it, we can send to the output the number NR has digits. But look, that thing here, like I told you in the arithmetic lesson, equals something like that. So it means that the number after that loop will be what? 0. So right now, oops, build and run. As you can see, the number 0 has 4 digits. So we have to create temporary variable that will store that number here. And now we'll divide the temporary variable. Because of that, we will not lose the value that is in that number, in that variable here. And now the number 1234 has 4 digits, and as you can see, everything works fine. Now when I increase that number, so it has 6 digits now, it will tell us the right result. So everything works fine. Now let's see how does it work. So while loop is working like that, when the condition is 0, it will stop execution, right? So at the beginning, the temporary variable is what? Is, let's back to that easier version, 1034. And then we are dividing it by 10. So so it will be 132. Is 132 not equal to 0? Of course it's not equal to 0, so we are going to increase number of digits. So right now number of digits is equal to 2, and we will again check the condition, but first we'll divide. And is 12 equal to 0? No. So let's increase number of digits. Is 1 equal to 0? No. So let's increase number of digits. And now we have 0. So is 0 equal to 0? Of course it's equal, because of that condition is false, and we will not increase number of digits anymore. So that's how it works. Okay, that was some training. Now let's talk about the nested loops, where we can use them. What are nested loops? Where nested means that we can have one loop in another loop. Look, we might want to, for example, write a program that will be sending to the output the multiplication table. So how does multiplication table looks like? We have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we should multiply 2 by all the guys here. So 2 multiplied by 1, 10, 12, 14, 16, 18, 12, right? And now we can a bit format the thing here so it will be more readable. And as you can see, it is the multiplication table 2 on 10, but most time would like to have something like 10 on 10. So I have to what now multiply 3 by again deadline here. Remember, by again deadline here. Okay, so 3, 6, 9, 12, 15, and repeat. And now 4, 5, and just repeat that, right? Right. So all the time we are doing what? Multiplying that guy here by that line here. How to create that line here? We can create it by using, for example, a loop for. So for, and let's define integer number I. For example, let's start it. Let's assign value 1 to it, and if 1 is lower or equal to 10, keep doing that instructions that are after the loop. And let's increase after each round that variable. Now we can send to the output I and then add the space at the end. And let's see our result. As you can see, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it just achieved that first line here. Let's get that guys into the multi-line comment because we don't need to see them now. So we have that line, and right now we would like to multiply, for example, 2 by that guy, 3 by that guy, 4 by that guy. Again, so we want to multiply, for example, like that. So, and then we have what? The second line. If I multiply by that guy, I will have the third line, right? Okay. So we need something that will change here, like that. Okay. So how to achieve that? We can use the nested loops. So I will have a loop inside a loop. So now I will create another loop inside, another variable, another condition, and I will multiply I by G. And now I will add here the end line like that. And let's see how it works. As you can see, we have got right now all the lines here. Everything works fine.